So in this video, we're gonna look at some about trig functions. So let's start with the sine curve. The general equation, let's go f of x. F of x is equal to sine a sine x. Let's be in front of this x. Let's put a b. Let's open a bracket. Let's say x minus p, close bracket, and our q. This is our general equation, right? Over here, I've drawn a Cartesian plane for us. Let's just go draw like a normal sine curve. This is freehand, so it looks something like that, right? Or maybe even let's make this a bit bigger because we have some more space. So our sine curve generally looks like this, right? Where let's call this the mother graph. So this is the one that hasn't changed. Either the a value, b value, p value, q value is all 0 or 1. That function would go up until, let's say, 360 degrees to complete the wave. Half of that is 180. Okay, half of the half, that's 90. And the upper part over here is going to be 270. This generally goes up to 1 and it goes down to minus 1. Okay, so this you know out of your head. This is our y-axis and this is our x-axis. This you know off by heart, right? This is the sine function that hasn't changed, hasn't moved. Now, so this function, let's call it, let's say y is equal to sine of x, right? Now we notice that a value there is 1. This b value is also 1. The p value, so if there was a bracket, there's minus 0 as your p value. And so let's put that 0. And our plus q here is also 0. Okay, so this function that you have over here, which is our mother graph, I'm just going to put it here again, sine x. Okay, so what does a do? Okay, so we know all of these things. I'm not going to spend too much time on showing you or redrawing it or something like that. But if a changes, that impacts our amplitude, right? Amplitude. Okay, so what is amplitude? Amplitude is from our resting point, from the middle of the graph. So let's call this the resting point. Okay, from that line up until the maximum, how many units is that? Now that for this graph is 1 unit. And because it's 1 unit, our amplitude is 1. If you want a formula for amplitude, that's fine. We've got one. That's going to be the maximum value of the function. So in our case, that's going to be the 1 minus the minimum value of our function. In our case, this is minus 1. So let's just go put that in here quickly. And then we'll divide this by 2. Okay, so we're going to say our maximum for our function is 1 minus our minimum is minus 1. Divide this with 2. Minus minus gives us plus. So that's plus plus is 1 plus 1 is 2 divided by 2. It's still just 1. We could see that from our resting point to the top of our function. So if we change this a value and maybe we make it 2, that would tell us that this graph goes up to 2 and down to minus 2. If we were to change that, let's make that 1 again. Okay, so a is our amplitude. Let's talk about q next. So the next value is q, and q shifts our function, right? Shifts our function up and down. Okay, so if we were to take our same graph, right, let's say this is my Cartesian plane, and I move this whole thing up and I make a sine curve there, right, where my resting point is now somewhere over here, and let's maybe make this 2. Okay, well, that point doesn't really matter, but what the number doesn't matter. What I want us to see is that this was the mother graph, just shifted like maybe 2 units up. Okay, so then this would be my q value. My q value is my new resting point. Q shifts up and down, and let's say it determines a resting point. Okay, great. So if I were to say this is a sine curve, so y equals sine x plus 2, because, well, that graph moved up 2 units. So from there, it went up twice. Okay, that's why that is 2. Okay, for that picture, there's probably another change also, but that's not the point. The point is this q value impacted my shift. Okay, so this is probably a 2 there as well, because that's 2 spaces from the resting point to the minimum. Anyway, that's not what I wanted to see. What I wanted to see here is that the q value is 2. This q value, maybe let's not circle that x, this 2 impacted this resting point. Great. Let's talk about B next. Let's do B next because we'll do P last. P is our grade 11 shift. The rest is grade 10 shifts. So B, let's say it impacts our period. So what is period? Period is how many degrees. How many degrees to complete a wave. Please remember this. The B value is not the period. The B value helps us find the period, right? Even my grade 12s are making this mistake. So if, for example, in this one, the mother graph that we've drawn, right, our B value was 1, the period is not 1. The period is 360 because it took 360 degrees to complete a wave. Okay, so period is how many degrees it takes to complete a wave, right? So if you want the formula, let's say period is equal to 360 divided by my B value. So if I were to make my B value 2, then my period would be 360 divided by 2, and that would mean it would take 180 degrees to complete a wave, right? Let me just draw another Cartesian plane here. And if I draw this and I draw, let's maybe say 2, okay, these are two sine curves. I know it doesn't look too pretty, but there's 360 degrees, off of that is 180. So here it took 180 degrees to finish 1, okay? Here my B value is going to be 2, but my period is 180. Okay, so what am I saying? Our B value tells us, so let's do this. B, how many waves in 360. So if B is 1, as our mother graph was, then there's 1 wave in 360. If B is 2, as this picture as over here, so this graph would be y is equal to sine 2x, right? This B value is 2. Then I have 2 graphs, or 2 curves rather, in 360. Okay, so that's A, B, P, A, B, and Q. All right, so P is our left-right shift. I think let's leave P for the next video. Okay, so here A, B, Q. Thus A, B, and Q is the same for the sine, same for the cos curve as well. Right, let's maybe just put a cos curve up here. So this is my mother graph for the cos curve, where my max is 1, minimum is -1. Takes 360 to complete the wave. That's 360. Half of that is 180. Half of that, okay, my drawing is not too nice, but that's 90. And this is the other half, which is 270. Okay, that's our mother graph for the cos curve. A, B, and Q, as well as P, will do all the same things. So if A changes, then this would go higher and lower, maybe if A is 2. Right? If Q changes, the resting point, which is currently here, would go either up or down. And then B also impacts how many waves we see in 360 degrees. We'll cut it here. The next video, we'll talk about P, and then maybe also I'll talk about drawing the graph within different restrictions. Let's cut that.